Hey everybody, I am home today as my daughter is not feeling great. At least she wasn't this morning. My guess is she will recover shortly, but it means that she needed some help at home. So I'm going to try and explain quickly two things that I wanted to explain in class, and hopefully they will help you with both um, your lab, where you're determining the relationship between the string length and the period of the pendulum, as well as the assignment number 24, which is the simple harmonic motion practice. That assignment on the second question has an idea that I'm going to use in order to talk about the lab, which is called linearizing data. Linearizing data is a way of essentially determining the relationship between two quantities, um, and so to be able to see what those are. And it's a tool that gets used quite frequently in physics and can be very powerful. I did include a video where a gentleman goes on and on about all sorts of different linearizing techniques, and you're welcome to watch that a little bit later in the slide deck if you want. But we're going to go ahead and start here and look and say, okay, so we looked at string length for the period and the period of the pendulum itself. It turns out that if you have a graph like this one here, and you wanted to figure out exactly what kind of relationship this is, this table on the left is useful. Well, you'll notice that I have all these different types of relationship. The first one is a non-relationship, which means as x increases, y doesn't change. The second one is linear in and of itself. And if you have a linear relationship, there's no reason to linearize the data, for it already is a one-to-one kind of ratio that's there. On the flip side of things, something like an inverse graph or a graph of an x square or a quadratic here, or even this one down here, which is a y-squared graph, or another way to think about that is a square root graph. Those might serve well to go ahead and linearize the data to be able to see, to make sure that that is in fact the kind of the relationship itself. So what I'm going to focus on here is looking at this graph here on the right-hand side, which is the graph of my string length versus period. And notice that it is not linear. There's a bit of a bend down here at the bottom, even though it looks kind of linear at the top, definitely not linear down below. And I'm going to go ahead and choose this last type of graph here in order to kind of get there. And if I choose that last graph, that is a graph of either y squared versus x, or the inverse of that, which is y is equal to the square root of x. You can see that here. So I'm going to go ahead and flip over to Google Sheets to help me out. And I have my graph here that I just did of my string length versus period. But instead of graphing string length versus period, I'm going to go ahead and graph period versus, again, this is the y, versus the square root of my x, or the square root of my string length. So I'm going to go ahead and say the square root, and I'm going to use this SQRT of string length. And to do that, I'm going to say equals SQRT, because that's the way it works it. And then I'm going to drop in 5 here, because the first one. And so I'm taking the square root of my x value, and that comes up here. And it goes ahead and says, hey, do you want to do that for all of the different values of x? And I'll say, sure. So there they are. So then I'm going to go ahead and graph this square root of string length, versus the period instead. And if we do this right, if I have truly a relationship that is square root of x equals y, then we should see a line instead. And so I'm going to hit insert chart, and there it is. And that clearly is a nice linear relationship. Now the dots get closer together. That's the nature of this linearization, but it is definitely a line. And if I want to, I can actually check this y equals mx plus b kind of relationship here and find out what is the slope of this line. So I'm going to come over and click on series and go down to insert a trend line, and linear is fine because it is definitely a line. And if I put in my label of my equation, I get this kind of y period is equal to m, that's the slope, times x. So y equals mx, and then I've got this plus b at the end, but the plus b is so darn small here, times 10 to the negative 15th, that really I don't even have to worry about that. So I really have the slope of 0.2 times this x, and my x is the square root of the string length, which if I go back over here and I take a look at my other graph, I went ahead and put in, pardon me, I put in a trend line for that already, and the trend line has this equation up here. But if you didn't recognize this equation as a square root, because this is x to the 0.5, then it is important to know that that's what I have down here. So when I took that on. So these two equations are actually the same thing because I'm graphing versus the square root of string length here, and I'm just graphing versus the string length here. And if it's x to the 0.5, right, that's the square root, or in this case, y equals mx plus b, what I've got. Now, where does this come into play? Well, if I grab my pencil over here to be able to draw something, the equation that I've got is period t is equal to the slope m times the value of x, right? That's the kind of relationship. And x in this case is the square root of the string length. Just a second, Acacia. I'm going to, yes, if you'd like to. So I have the period is equal to the slope times the square root of the string length. And that's my relationship. If you look up the relationship online as to what this kind of relationship is overall, you will find that it is period is equal to 2 pi times the square root of the length of the string divided by the acceleration due to gravity. Now, are these two things the same? Well, if you put in the value that we have for slope here, we get t is equal to 0.2, right, times the square root of the length of the string. And if you were to solve this here and say 2 times pi is 3.14159, so on and so on. If I take that and then I multiply that times the square root of 1 over g, so this would be 2 times the value of pi times the square root of 1 over g, and then you multiply all of that times the square root of the length of the string, this whole quantity here, which on Earth, right, has a very known value for g, and because we're doing things in centimeters, if we use 980 centimeters per second squared and multiply that times this 2 pi, you would end up with 0.2 times the square root of the length of the string. Gage is trying to get my attention, yes? Yes, that's fine. All right, so notice that they are the same. We just have some values that are already solved for here. So that's how you linearize data. That's how I might kind of show kind of the relationship and the connections between those things. Hopefully that's helpful. And the video is already getting long, so I'm going to go ahead and sign off here. So take care and good luck with your assignments.